and welcome to the second tutorial on IBM Watson Visual Recognition Tool. So in this video we'll show how to create a custom classifier of any object and train it and query a custom classification. And the custom classification result will show you the either in the form of a faces, text or any objects. Earlier we have shown how to classify an object using a pre-trained classifier, and now we'll create a custom classifier of that particular object. Now the question is why we need to do this. Its application is enormous. First, if we want to do a damage detection of any car after accident for insurance claim, so that case we need to take the photograph of the damaged components and we'll train it with respect to the custom classifier that and we can identify the percentage of damage and which will help us to get the insurance claim, and it will be done automatically without any manual intervention, and when the accuracy level is also high. Another example may be the remote monitoring and maintenance of any mobile tower. The mobile tower physical damage can happen due to the weather and the rusting and iron rusting and other things are happening. So instead of taking the manual photos, we can take the photographs of the damaged components through the drone and send it to the custom classifier, and custom classifier also again give you the output of the percentage of damage detection, and so that the repairing can take place, and immediate attention can be taken for that particular component. And similarly you can identify the freshness of any fruit or food items with respect to the freshness components which is already pre-trained within your custom classifier, and you will find out the percentage of freshness of any food, and based on this you can determine the price of that particular food. Now, the how this custom classification is being done. Suppose if we take the examples of the fruits, different fruits. Now, if we want to classify, create a custom classifier of the fruit classifier, that case we will take the images and create the data sets of the images of the different fruits like apples, bananas, pears, that it is showing over here, and these are considered as the positive examples. Now the question is, if you give an image of an apple as an input image, and it will show you the percentage of accuracy and the confidence level and confidence score, that how much it is matching with apple. Now instead of apple, if you give a vegetables, so that case it will try to match it either with the apple or bananas or pears. Now it will try to show you the percentage of accuracy with respect to apple, bananas or pears, which is a wrong result. Now to get out of this problem, what we have to do, that we have to create a negative examples. That means we have to create a training data sets of the negative values which are not likely to be fruit. So vegetables will comes under this negative examples. Suppose if we don't give this negative classifier examples in our custom classifier, and if we put a zucchini as an input classifier, so that case what will happen, that zucchini is a vegetables, so it will try to give you the confidence scores that it is quite like apples is 82%, which is wrong. Now instead of only using positive classifier, if we put the negative classifiers as a vegetables as an example, where we'll put zucchini as well as the broccoli or the other vegetables also under this negative classification of images in the fruit classifier, that case, and if we put the other fruits examples, and what we will get, that if we put zucchini as well as orange, we'll find out that when you are putting zucchini, the apple's value is 0.02%. That means the confidence scores gets degraded and your result accuracy will be higher. So your results accuracy depends on how good you are training your custom classifier as well as how many negative classifier you are putting into your example. Now let us going into the details how we will do it using the IBM Watson. Now this is my IBM Watson account. Now my dear students, as you already have the IBM Watson Lite account, the sorry, the limitation of the Lite account is that you can create only one services and one IBM Cloud account within this Lite account. So if you have already inbuilt services or any storage account is storage services you have already taken, you have to delete all those services to create your own custom classification services. Suppose here I have already one inbuilt services is present. Now first of all I have to delete this service. Now sometimes we get confused that which services to delete. That case what you have to do that if you don't find any services, then start trying adding a new services and start your work. And whenever you will stuck, that means it will tell you that already one service is running, you have to delete the services. It will show you the number of services that are running and you can delete those services. Now I am deleting my existing service. Now I am adding a new service. It should be a visual recognition service under the Lite account. So delete all those services and whatever storage instances you have created and start a new project. Now add a project. What type of projects you want to add? That is visual recognition service. Now create a visual recognition instance. Now earlier we have taken these pre-built models, general, food and explicit. Now we'll create a classify image, create a new model. Now our main task will be to create a custom classifier that will identify chair, table and bed. So for that we have to download the different images, high resolution images of chair, table and bed, and keep separate folders for chair, table as well as bed. And you have to keep it in mind one thing, that as you have taken the custom classifier in the light account, the total size of those datasets should not exceed 250 MB. Now I have already created data sets of light those beds and chair and table, and it has already is uploaded in my Google Drive account, and I will share the link in my description box so that you can use this one. So this is the data sets that I have created. So one is the bed with positive examples, and remember one thing, you should have at least 10 images for accurate 10 data sets for your custom classification. If the number of data sets increases, your custom classification accuracy will be more. And here I have 23 images. Similarly for chair also I have created one data set, and for table I have created one data set. And if I give as an input to any images which is, does not falls under table, chair or bed, that case it should be under the comes under the negative examples. So I have created another folder for furniture with the negative examples, so it should comes under the negative classifier. Now convert all those data sets into a zip file. So zip file, it will help you to upload those images within your IBM Watson perfectly. So this I have these data sets with me. Now you can create your own data sets for different objects. So I'm uploading those zip files. It will take some time. Now all the videos are being uploaded. Sorry, the images. Now you can see that the bed positive examples are there, bed chair positive examples are there, furniture negative examples, and chair positive examples. Now you can see the examples. So these are the beds examples. Now at the time of taking the photographs, you have to be rest assured that you have to take the pictures of bed from different angles so that the custom classifier can create the classification and the training uh, mm, robustly, so that any type of bed comes as an input, so it can the confidence score should be high. In case of chair also, you have to include different types of chairs. Now in the furniture negative examples, what we have given, that the different types of furnitures which the systems may get confused, for which the systems may get confused that whether it falls under chairs, tables or bed, the system doesn't know. So in that case you can use this example. Now you have to train that one. Now at the time of training, the training it will take some time, and you can see that the total size of the image is 137 MB out of 250 MB. 250 MB is my total capacity. Now train the model. Now training will take some time. So after 15 minutes of training, the training is now successful. Now you can see that after training, you cannot add any other images until and unless you go for edit and retrain the model. So you can see that all the images are being logged now. Okay, now let us try to test and check that how much confidence accuracy we gain from this training of this custom classifier. So I have some test images are there. Now look at this. The training is not that much good. That is why table it is showing 0.76%, chair it is showing 0.41%, furniture negative example. Actually, no, it has not taken it as a negative example. Now let us check with other one. And another thing also you can do that you can remove the confidence score which values are 0. Less than zero point 0.5. So what you have to do that you have to put the threshold value as 5.52 or like this one. Now what we will do that we will clear the result and take another example. Suppose for this chair, let us take this chair and look at this. For bed and table it is comes under less than zero point 0.5, that is why it is showing 0.00, but the chair custom classification is done pretty good. So what we have to do that for the table we are not getting good confidence score. So what we can do that we can put more tables examples over there and we'll retrain it and we'll check that how it is now behaving. Okay, so now check for the bed also. Now for bed also you are not getting very good results. Now instead of a single value you can take multiple objects and take the overall results also. So put all those objects together and check the results and you can make a comparison of these results. Table the result is not that much good. Chair the result this one is loading still now, and for the bed the result is not that much good. Now let us wait for the chair, and by this time we can add more table into our custom classifier. What we have to do that whatever images we have taken, put all those images, take all the image values over there. Now first of all this furniture negative we have to put it in the negative examples. So how to do this? So we have uploaded the examples of tables, and we will upload the other examples also, like chair and to bed. All examples we are uploading over there. Now what will you do that? We'll include them under which classifier? These are all table, right? So table classifier. Submit. Now let us take this bed example and put it under bed positive example, and this chair will put it under chair positive examples. Now we'll retrain it again. Okay, now the training is successful. Now what will you do that? We'll check the result again. Now look at this. Now the table result is coming good. Now let us take all the examples and how they are behaved. Now all the results are coming more than 90% or 80%. 80% and more, the result confidence score is a little bit good. Now, if you take any other chair example, suppose if I take any other chair example and let us check how it behaves. And also we'll take one bed example also. And test it. Now, new chair and bed examples we are taking, and let us see. In this case also, it is giving quite good results. So I hope you have understood now what is your task. You have to create the similar kind of furniture model custom classifier, and you can use my dataset, or you can take the datasets examples from Google But remember one thing, it takes only the JPEG image. PNG or TIFF image are not allowed. Another site from which you can take the images, that is unsplash.com. Unsplash.com. So here you will get some high resolution images. So take the images, create your own custom classifier, and check your results and apply it in some other applications. So for the time being, bye bye.